Here we have the second video on linear programming problem. If you remember, in the first video, we discussed about the definition, theory, the structure of an LPP, and some different terms and terminologies that is involved in this chapter. Okay, so as you all know, an LPP has three parts: objective function, the linear constraints, and the non-negative restriction. So here in the second video, we will learn about how to convert a mathematical problem, word problem, as you all can see in the screen here, into a linear programming problem, that is into equations, and how can you solve it. Okay, so before we read out this question and then start solving it, we will first see what are the different steps involved in formulation of an LPP. How would you convert a mathematical word problem into a linear programming mathematical problem? Okay, so let's see. Step 1. Step 1 says identify the decision variables and assign symbols to them, say x and y. Decision variables are very important. Decision variables are actually the variables of an LPP. Okay, we have to identify that. Step 2 says identify the objective function and express it as linear function of a decision variable. Objective function, you already know, an LPP always has an objective function. It has three parts. One is the objective function, very important. Step 3 says identify the constraints. You know, the second part, the constraint we have to identify and express it as linear equation or inequations. And finally, write down the non-negative restrictions. So this step 2, 3, and 4 are the normal steps that is involved in an LPP, because an LPP will have an objective function, constraint, and a non-negative restriction. So first and foremost, we need to identify the decision variable. So let's go to the sum. You may copy this sum, pause the video and copy this sum. Then we will identify the decision variable. So before we start, because decision variable are the variables of an LPP equation. Let me read the question. A company manufactures two types of novelty souvenirs made of plywood. Souvenir of type A requires 5 minutes each for cutting and 10 minutes each for assembling. So listen here. To make souvenir, you need to cut it and assemble it. So different time for cutting and assembling. Souvenir of type B requires 8 minutes of cutting and 8 minutes of assembling. Here you have different timings. There are 3 hours and 20 minutes available for cutting. You can't cut that product unlimited time. Okay, there is a certain time frame for cutting it, and that's 3 hours 20 minutes, and 4 hours available for assembling. The profit is rupees 5 each from type A and rupees 6 each from type B. See this properly. Type B gives you more profit than type A. How many souvenirs of each type should the company manufacture in order to maximize the profit? So with the required resources that we have, the plywood, and the required time frame, 3 hours and 20 minutes only available for cutting and 4 hours for assembling, how many of each type should we produce? You may think we may produce more of type B because it has more profit. But remember, type B may require more time for assembling and cutting, whereas type A might require a little less time for cutting and assembling. So we need to balance this. Which one should we produce more, or what quantities should we produce each of these, so that we will have maximum profit from these souvenirs. Okay, so that's what we are going to learn in this video. So let us identify the decision variable. Okay, so the first step was to identify the decision variables. Decision variables are the quantities that need to be produced, or you may say the quantities that is to be found out in the question. Okay, so according to this question, it says here, let me highlight it. How many souvenirs of each type should the company manufacture? So look at this highlighted line. How many souvenirs of each type should the company manufacture? This is our decision variable. So we write it down. We'll assign variable to it, and we will write down let the company manufacture X units of type A and y units of type B souvenir. SUVENIR. Okay, so we put it this way. So let me highlight it. We say that the company produce X units of type A and Y units of type B. So these are our decision variable now. Okay, so this sum is all about maximizing the profit. Look at this highlighted line here, maximize the profit. So we know the objective as to sum is to get maximum profit out of it by making type A and type B. Okay, so before we go to the second step, I think it will be very easy for us if we can convert this LPP, if you can convert this sum, in a tabular form, if we can express it as a table. So what we will try to do is we'll try to make a small table. So make a small table here, and then we'll try to fit in all the data that's given in this question in a tabular form. Okay, so the first column I have here is for souvenir. There are two types, A and B. Okay, the second column I will make here would be quantity. That's X and Y. The third column I'll have here, let's see what else is involved. So how to make this souvenir? By cutting and assembling. So I'll make manufacturing process. So that's cutting and that's assembling. Please try to make sense out of it, cutting and assembling. Okay, so here we have the third column, profit. We are talking about profit in this sum. Okay, so let's read the question and try to fill up this table. So manufacturing process, as you all can see here, I'll highlight it for you, the manufacturing process here. So what is involved? Cutting and assembling. Let's see how much time is required for cutting type A and how much time is required for cutting type B. Okay, so let's read the question. Here, let me highlight it. Souvenir of type A requires 5 minutes each of cutting and 10 minutes each of assembling. So I'm going to write this down. So souvenir of type A, 5 minutes for cutting and 10 minutes for assembling. Let me see the second one. Souvenir of type B requires 8 minutes of cutting and 8 minutes of assembling. Let me write that down as well. 8 minutes of cutting and 8 minutes of assembling. And profit, let's see, fill up the profit column as well. The profit, the profit from is ₹5 for type A and ₹6 for type B souvenirs. Let's fill it up. That's ₹5 for type A and ₹6 for souvenirs. Okay, did we miss anything? Yes, we have here total availability. So let me see here again. There are 3 hours 20 minutes available for cutting and 4 hours available for assembling. So we have to fill this up as well. So I will make an extra row here and I will write it down. Total availability. How much do we have? For cutting, I have 3 hours and 20 minutes. So I'll have to convert that into minutes and write it down. So convert 3 hours 20 minutes into minutes. How much would that make? 3 hours would mean 180 minutes plus 20 would mean 200 minutes and 240 minutes for assembling. Okay, is that clear? 3 hours 20 minutes would mean 200 minutes and 4 hours would mean 240 minutes. Okay, so I have converted the whole sum in minutes. So this is what I have here. This is the table that I was talking about. I have converted the whole table that you can see here, whole sum, into a tabular form. Okay, so we have converted into a tabular form. Now this makes doing a sum very, very easy because from the table we can directly frame the LPP. Okay. Okay, so let's start framing the LPP. Now we have already assigned, let's follow the steps. Step 1 says identify the decision variable and assign symbols to them. This is done. Identify the objective function. What is the objective function in this sum? As I've already told you, to maximize the profit. So I will write it down here. Maximize Z equals to, so Z stands for profit here. So what is the total profit that you can make from type A and type B? You know that from 1 unit of type A, you can make 5 rupees profit. Rupees 5 profit is from 1. But how many are you making? X. So how much is the total profit? 5x. That's from type A. And 6 into y, that's 6y. That's from type B. So that is my objective function number 1. Great. Let's make the constraints now. Subject to. Third step says identify the constraints and express them as linear equations or inequations. It can be anything. Let's see. So to make the constraint, what are the conditions? What are the limitations, by the way, for this? These two columns, as you all can see here, cutting and assembling, these two are the constraints. So let's make an equation or an inequation from this constraint. So for 1 unit of type A, you need 5 minutes for cutting. So for X, you need 5x minute for cutting. Plus, for 1 unit of type B, you require 8 minutes for cutting. So for Y, it will be 8y. So 5x plus 8y would be the total time only for cutting. And how much time do you have for cutting? 200 minutes. That's the total availability. So 5x plus 8y, that is the total time for cutting, has to be less than equals to 200. So that's how we put symbols, okay? Because the question says there are only 3 hours and 20 minutes available for cutting. You can't exceed more than 200 minutes. So that is my first constraint. The second constraint, quite clear here, 10x plus 8y, because 10x plus 8y would mean time for assembling type A as well as time for assembling type B. Total time for assembling only. And how much time do you have here? Look at the circled one here, 240. So it has to be less than equals to 240. So that is my constraint 1 and constraint 2. I have 2 constraints here. After that now, since you have made the objective function, you've also made the linear constraints. Finally, step 3 says write down the non-negative restriction. It is very easy. All the non-negative restriction are very easy. You just have to write in each and every most of the sums, x has to be greater than equals to 0, y has to be greater than equals to 0. That is the constraint. In most of the sums, you need to write this: x greater than equals to 0, y greater than equals to 0. So that is what I have. So finally, we have completed the LPP. Let me show it to you here. So I have, this sum is all about maximizing the profit here, the highlighted one, the blue highlighted one. So you have to maximize this z, which is given by 5x plus 6y, and the constraints that is involved in this sum is 5x plus 8y, which has to be less than equals to 200 because that is the total time for cutting, and 10x plus 8y, that's the total time for assembling, has to be less than equals to 240, and the non-negative restriction, x greater than equals to 0, y greater than equals to 0. So that's how we form an LPP. In the third part, I'll teach you how to solve it as well.